Welcome back, everyone. We're going to continue our section on angles. We were drawing angles last time. This time we're going to talk about drawing angles and finding reference angles. So a reference angle for theta is the acute angle. They call it theta prime, formed by the terminal side of theta on the x-axis. So that's the formal definition. I have my xy axes, 0, 90, 180, 270, and 360. And I want to draw 228 degrees. 228 is positive, so we're going counterclockwise. And it's in between 180 and 270, maybe about right here. So this is the angle that we've drawn. To find the reference angle, remember this is the x-axis, this axis right here. So we go to our nearest x-axis to find a perpendicular line to it. And this angle that's right here, tucked up by the origin here, is your reference angle. To find the measure of that angle, we take the angle that we drew, which was 228, and we drew that line to 180 degrees. And we're subtracting. So 228 minus 180 is 48 degrees. So the reference angle is 48 degrees. So here are the steps for finding our reference angles, the ones that I just did. Gives you a way to find out the measure, because the biggest thing about the last slide and a reference angle is that reference angles are acute, which means they have to be in between 0 and 90 degrees. They have to be between 0 and 90 degrees. And no matter what, they are always going to be positive. Always positive. So let's try a few. I'm going to draw. These are all positive angle measures. So we're going counterclockwise for all 4 of them. And our first one is 130 degrees. 130 is between 90 and 180, maybe about right here. So there's my angle. Now for the reference angle, remember this is our x-axis, and we always draw those perpendicular lines to the x-axis and only the x-axis. So our nearest x-axis is here at 180. There's my perpendicular line. The reference angle always has to be right here, touching the x-axis and the origin. And then to find that measure, I'm going to do 180 minus 130 to get 50 degrees. So the reference angle is 50 degrees. All right, 575. 575 is more than 360, so we're going to subtract 360 from it and get 215 degrees. 215 degrees is in quadrant 3. It's in between 180 and 270, roughly about right there. So 360 and 575. That means our theta is super small up there in that corner. Again, it's always got to touch the x-axis and the origin. Our nearest x-axis for our perpendicular line is the 180. And this time I'm going to use the 215, the extra 215 that we went around to get to our 575. So we can do 215, and we went to the 180 degree x-axis. 215 minus 180 is 35 degrees. So our reference angle is 35 degrees. 35 degrees is between 0 and 90. So the measurement works, and it's positive. All right, our next one, 300 degrees. 300 degrees is in quadrant 4. It's between 270 and 360, roughly about right there. So there is 300 degrees. Now again, our nearest x-axis is up here, all the way up here. We kind of want to go to the y, but you can't. You always have to go to x. That makes our theta tucked in right here, touching the origin and the x-axis, always, always, always. So we went from 300 up to 360. We're in quadrant 4. 360 minus 300 is 60 degrees. So our reference angle here is 60 degrees. 60 degrees is between 0 and 90 degrees, so it works. All right, 420 degrees. 420 degrees is more than 360. So I'm going to go ahead and subtract 360 and find out how much further do we need to go, which is 60 degrees. So we're going all the way around and then an extra 60 degrees. An extra 60 degrees stops in quadrant 1, roughly about right here. So all the way around and then here. Our nearest x-axis is down here at 0 because we're in quadrant 1. And that makes our theta right here, tucked into the origin, touching the x-axis. So remember, we're not going to use the 420. We're going to use the 60 degrees. And in quadrant 1, we go to the 0. So 60 minus 0 is 60 degrees. Our reference angle is 60 degrees. Is 60 in between 0 and 90? It is. So that works. We'll try a couple more. Again, these are all positive angle measures, so I'm going to go counterclockwise. And start with 45 degrees. 45 degrees is in quadrant 1. There's my terminal side. We went like that. Our nearest x-axis then is down here. Remember, this is x. And our theta is tucked right here. Always touching the origin, always touching the x-axis. Quadrant 1, our closest x-axis is 0 because we started from 0 and just went up to 45. 45 minus 0 is 45. So that makes our reference angle 45 degrees. Is 45 acute between 0 and 90? It is, so it works. All right, 250 degrees. 250 degrees is in quadrant 3. It's between 180 and 270, roughly about here. Our nearest x-axis is the 180. Remember, you can only ever go to 0, 180, or 360. Those are the values on the x-axis. Our theta is tucked up in the corner over here, again, touching the origin and the x-axis. Always, always, always. So we have 250, and we went to 180. 250 minus 180 is 70. So our reference angle here is 70 degrees. Is 70 acute between 0 and 90? It is. So that works. All right, 395. 395 is more than 360 degrees. So we're going to subtract 360, and we get 35 degrees from that. 35 degrees stops in quadrant 1. So maybe here. So we go all the way around and then to 35 degrees. Our nearest x-axis is going to be here at 0. Theta is going to be tucked in that little itty-bitty corner there. Always touching the origin, always touching the x-axis. And remember, for our purposes, we're not going to use the 395 for our reference angle. We're going to use that 35. And we went from 35 down to 0. 35 minus 0 is 35. So our reference angle is 35 degrees. It's 35 acute between 0 and 90 degrees. It is. So that works. All right, everyone. Start working on that practice page. And if you need any help, reach out. Talk to you soon.